Here's another example of solving systems in which we get strange results. So, when you have these two equations, I'll decide that I want to get rid of the x variable. We could do the y, but I'm going to do the x. So I'm going to multiply the top one by 2. And I'm going to multiply by -2 so we can add them. So -6 times -2 is 12. And then 3 times -2 is -6. And then -15 times -2 is 30. And then we just rewrite this equation. And we can add them together. And like I wanted, the x's are going to cancel. But then -6 plus 6y, that cancels out also. And then the 30's also cancel out. So you have 0 equals 0. So if we recall back to when we would solve an equation for a variable, and we had a number equals another number. So it's not like x equals something or y equals something, but a constant equals a constant. That meant that there is an infinite number of solutions. So when we're solving systems, we're looking for where the two lines on a graph will cross. So it's just strange to think that they cross an infinite number of times. So we can graph it to see what this really looks like. So we have to rewrite them in terms of y. So this first one, you can add x to both sides. Plus 6x. Then divide by 3. And then if we take the second one and add 12x, and then divide by 6. And then we have these two equations, and I'm just going to rewrite the -15/3 as -5. And then -36 as -5. And we can see here that we have the same exact equation. So that's why we have an infinite number of solutions. If we look at a graph, and graph these two lines, you have a scale of 1 here. Y-intercept of -5, and then slope is 2, so up 2 over 1. And then I'll draw in the second line, -5 up 2 over 1. It's the same exact line. So when we look at where the red line and the blue line cross, they cross in an infinite number of spots, because for every x and y value on the red line, it's the same x and y value on the blue line.